really what I'm doing here. So deduce the reduction formula. All right, and we want a Tn minus 1. So I'm going to save that x to the n for differentiation. And I'm going to then integrate the 1 minus x part to the power of a half. I'm going to integrate that one. All right. So my to the n is going to equal, so when I do integrate that one, I'm going to get 1 minus x to the power of 3 on 2, 3, 2, and there's a minus inside, so I should have had a minus there as well. And then I'm going to leave my x to the n alone because I want to differentiate that one. Alright, so I've got, so what I did was put a minus out here and a minus there as well. So usually I would have a minus here, but it's going to be minus minus, so that's now a plus. So I'm going to run out of room because I wrote it too high, but I've got the 1 minus x to the 3 on 2, and I've got the 3 on 2 there as well. And then if I differentiate x to the power of n, the n will come down the front, and then I have n minus 1 dx. Alright, now you can see if I substitute the 1 in, I'll get a 0 here, and the 0 in, I'll get a 0 here. So that whole front bit is just a 0. Alright, so then what have we got? We've got 2n on 3, and here we've got Alright, so we might break this up. So you can see that we've got a square root. So if I write it out here, I've got 1 minus x to the power of 1 and 1 minus x to the power of a half. That's 1 and a half, or 3 on 2, and then x to the n minus 1. So I might go 1 times that, and then minus x times that. So I can break it up into 2 integrals then. So then I'll get x, they're both going to have x to the n minus 1, and I'm just going to have the square root 1, and then I'm going to have minus, because I've got minus x here, this one. So I'm going to have minus, but still 0 to 1. Now this is going to be x times x to the n minus 1, so that's xn. And it's still the square root there. Alright, so what does that give us? So this just gives us the Tn minus 1 integral, and this gives us the Tn integral, which is what we want. So putting it on the other side, I'm going to have 1 plus 2n on 3. Lots of Tn's. And of course that is the same as 3 plus, 2n on 3, lots of tn's. So if I want tn by itself, I'm taking the 2n on 3 and I'm multiplying by 3 on 3 plus 2n. So we're going to get 2n over 2n plus 3, lots of tn minus 1, which is what we wanted for A. So there's a long bit of work for A, but now B should hopefully be easier. So let's have a look at B. So B, we just want to show that T3 equals 32 on 315. Alright, so let's check that it does. Let's start with T0. So T0 would be 0 to 1, 1 minus x to the half. Dx, put a minus there. Do we don't need it. Okay. Alright. So I'm going to get 1 minus x when I integrate to the power of 3 on 2 on 3, 2, minus there, and I'm doing it between 0 and 1, which gets me minus 2/3 of 0 minus 1, which is just 2/3. So T0 is 2/3. Let's go to, because I know I'm going to need that, let's go to T3. Alright, you can see T3 using our reduction formula is going to be 2 3s, so 6 on 9 times T2. And T2 using the reduction formula, 2 2s, so 4 on plus 3, 7. Alright, now I've got T1. T1 would be 2 on 5, and T0, which we found. So putting all that in the calculator, hopefully we get 32 on 315. You can check that. All right, so use the reduction formula to help prove by induction that we have this expression here. All right, so while it looks a little bit scary, it shouldn't be too bad. Let's have a look. So if I look at using the reduction formula, let's start with Tn minus 1. So like when we're doing k minus 1 and we prove for t of k or k plus 1 given k. So we'll do the one before. So from our formula, we've got for t of n minus 1, it should be n minus 1 factorial, n factorial on 2n minus 1 plus 3 factorials times 4 to the n. Alright, so we've got n minus 1 factorial, n factorial. This will end up being 2n plus 1 factorial times 4 to the n. Alright, so we're going to use that using the reduction formula now. We know that Tn is 2n on 2n plus 3 lots of our Tn minus 1. So let's put our Tn minus 1 in here. Alright, whoops. Alright, and see if we can get this formula over here. I'm going to force it a little bit. So you can see on the top I've got the n factorial and the n plus 1 factorial. So here I've already got the n factorial, which is nice. I'm going to use this and bulk it up. So I'm going to make it an n plus 1 factorial. How am I doing that? Well, I've got to times it by an n and an n plus 1. So I'll times the bottom by an n and an n plus 1 as well. Alright, so I've used those two. If I just rewrite the rest for a second, I've still got that 2n from out the front, and I've got a 2n plus 3 at the bottom, and I've also got that 2n plus 1 factorial. I also want 4n plus, I want another 4 up there, so I'm going to divide by a 4 down here. Now you can see some of this stuff cancels nicely. That n cancels, this 2 cancels with that and becomes a 2. So now I've got what I want on the top. I've got the n factorial, I've got the n plus 1 factorial, and I've got that 4n plus 1 there, which is there. Alright, so I really just need 2n plus 3 factorial on the bottom. How am I going to get that? Well, I need 2n, I've already got 2n plus 1 factorial, so I just need a 2n plus 2 and a 2n plus 3. And you can see I've got the 2n plus 3. How am I going to get the 2n plus 2? Well, remember here we've got a 2 and here we've got a n plus 1. So that is, I'll just write the 2n plus 3 first. So that'll become 2n plus 2. And then I've already got 2n plus 1 factorial. So you can see, I'll just do it over here so you can see, I've got the top. Oh, nice. And now the bottom, I've got 2n plus 3 factorial. So it works nicely. There you have it.